All right, everyone, are you ready to talk about building extensible RPG systems with the gameplay ability system? So, yeah. So it's a mouthful of a name. Mostly what we're going to be talking about today is the perk system that we built for Towerborne. A perk system sounds like kind of a narrow thing for an RPG system, but it actually lays the framework for a lot of stuff. Our items use it, our skill tree uses it, some of our missions use it. And so it's a good overview of the kind of extension points that you want to put in an RPG system to kind of give you the flexibility and power to do the weird things that you want to do in a one-off RPG. Just weird stuff comes up in RPGs. And so this is the way you can build a skeletal framework that your designers can do the weird stuff that they want to do in it. Introduction slides are awkward. They're so awkward, I forgot to even put my name on this one. But I wanted to throw one in because there's a couple of things I want you to know about me before we get started. Not only that I have a cute cat, but I do have a cute cat. Together we have at least 4 brain cells. But also, hey, I'm a technical designer at Stoic. This means I'm in the design department, and we're going to talk a lot about implementation. There's a lot of screenshots of blueprints, but we're also going to talk about why we designed the perk system the way we did, and even why we built it in the first place. I also want you to know that I grew up in the sort of the gutters of the Southern California arcade community. I have a deep, abiding love of fighting games. I once walked from Glendale to North Hollywood because I spent my bus fare playing that one more game of Marvel vs. Capcom 2. I also have a deep, abiding love of MMOs. I was on the internet early. I was playing a lot of MUDs on my 14.4K modem. Thank you. Killing the Lich King is probably still the hardest thing that I've done in gaming. And I'm lucky enough to have gotten to work on fighting games. I'm really proud of the work I did on Skullgirls. I got to work on Guild Wars 2, Destiny, if you want to count that as an MMO. So I have this specialized knowledge of these specialized genres, and it's really great to get to work on one or the other of them. It's really rare that I get to work on both at once. So when I heard about Towerborne, I had to get involved with it. It is my peanut butter and chocolate put together. It's a multiplayer online brawler. I get to punch dudes, and there are stats, and there's multiplayer. Sign me up, right? I was very excited about it. Towerborne's built in Unreal 5.4. We're staying mostly up to date, not all the way. And it uses the gameplay ability system everywhere, right? It's an action game at its core, and so we use the gameplay ability system to power all of that action. Obviously, the attacks that players do are abilities, but also the reactions that players do when they get hit are abilities. Kind of anything a player does is going to be an ability at the end of the day. I also want to say that Towerborne is out right now. It's in Xbox Game Preview and Steam Early Access, and I don't only say that to shill, although yeah, please come play Towerborne. You're going to have a great time. But also to say that the systems we'll talk about today have at least interacted with real-life players some, and my engineers haven't come for me yet, so there's some evidence that this works in the real world. As I talked about earlier, Towerborne's a brawler, right? The core minute-to-minute gameplay is this action button-mashing gameplay inspired by 90s Capcom and Konami brawlers, by newer versions of the genre. There's a ton of fans of Streets of Rage 4 at the studio. This is the heart of Towerborne gameplay, is punching dudes and doing cool combos. Towerborne's also an RPG, though, right? Once you leave an individual mission, there's a big world to explore. You take on quests and make friends. You customize your character. There's an overly complicated skill list. And most importantly, you get loot, right? In the middle of this inner and outer loop of combat and RPG stuff lives progression and itemization. And I mean that literally, the screen that happens in between beating the boss and going back to the world is the one where you get all your gear and level up, right? So these systems have a really important job in the game of tying these two loops together to make sure that players feel like their investment in one loop is going to pay off in the other. And so when we were thinking about progression and itemization and what is its job, there's sort of 2 bullet points we gave to these things. We said, hey, these systems have to do these 2 things. The first is that they need to make a promise that every new item or skill or whatever a player gets is going to deliver a novel gameplay experience. It's not just enough to increase a stat. It needs to make some promise to the player that it's going to change the way they think about the game and maybe change the way they play the game. But it's not just enough to make the promise. We then have to deliver on that promise. We can't defy player expectations. Once they finally unlock that skill that they've been working towards, it needs to do the thing that they expected it to do. And because of this, well, sometimes the the promise isn't like the biggest promise in the world, right? This is an aspect from the game that gives you increasing crit damage as you do stuff. Every time you defeat an enemy, it ramps up through the whole mission. So by the time you fight the boss, you're dealing out big numbers. And it's not going to revolutionize the way you play the game, but it is going to make the player start asking questions like, how do I increase my crit chance? Are there different skills that I can use that I can guarantee a crit with, right? Like, it's going to change the way the player thinks about the game a little bit. Sometimes it's going to think about the way the player changes, like it's going to change the way they think about the game a lot, right? This is a legendary item that spawns a cool shockwave every time you do stuff, and it's rad, and I love it. And so when we were thinking about how do we make progression and itemization do both of these things, make small promises, make big promises, we decided on a perk system because we want to change the gameplay, not just stats. And we knew it needed to be powerful and flexible, powerful enough to do the big splashy things and flexible enough to also do the small things. And so that's kind of the tagline for today is powerful and flexible. So now we've settled on a perk system. Great implementation flows from solid design, and solid design comes from clear goals. So like, what are the goals for our perk system? What are we trying to accomplish with it? And the first one is the one that we already talked about, right? It needs to be powerful and flexible. It needs to let designers do the stuff that they want to do. OK, cool. I got some other stuff I want to hit on along the way, though. I want to use existing tech as much as possible, right? Engineering time is precious for designers. I want to work with the systems that we have in the game as much as possible. In Towerborne, that means using the gameplay ability system, right? It's the heart of our combat. We're trying to make items and skills that affect combat, and so we're using the gameplay ability system as much as possible. I also wanted to make balance tuning easy. I knew that the people implementing perks and the people balancing those perks are probably going to be different designers at the end of the day, so I wanted to make all the balance numbers centralized in one place. Ideally, we could even update those balance numbers live so that if we really screw something up, we don't have to like release a patch for it. Finally, the last thing I wanted to do is make each perk as modular as possible. If a perk modifies something, if it makes a player attack better, I want to make sure that the player attack doesn't have a bunch of branches in it and say like, oh, well, if the player has this perk, do this thing. If they have a different perk, do another thing. They should be able to attach themselves onto attacks that already exist, abilities that already exist, without having to put a lot of branches in code. That's the ideal, anyway. And so this is a pretty good set of goals. I'm pretty happy with it, except for this first one. This one sucks. Powerful and flexible, sure, great. What does that mean? Let's designers do what they want to do. All right, man, what do designers want to do? So we went in the tank. This is paper design, right? We can do whatever we want. We got our cowboy designers to do this, the ones that like really think out of the box. We generated a lot of ideas. And then from this giant list of ideas, we're like, how do we rake this into piles? How do we categorize this so that we have a smaller surface area that we're trying to hit? And we managed to take all this whole spreadsheet, group it into 1 of 4 categories, and fit all of these perk ideas into one of those 4 categories, or at least some combination of those categories. The first one is new abilities, right? Sometimes you just want to give the player a cool button to push that does a cool thing. All right, straightforward enough. Passive abilities, y'all are pretty familiar with this. You want a number to go up. You need a way to do that. No problem. Triggered abilities, these are events that you want to react to. The event's already happened. You know the result of that event, and you might want to act on that result, and you want to change the world some way because some cool thing happened. And then the last one is modifiers. This is the most complicated of the 4, but it's also one of the most useful. This is the idea that as an event is happening, you want to change some attributes about that event before the result is determined. So the example on screen, right, we have shield attacks do extra damage to a specific resource. I don't want to make an attribute for this because not all of our classes even have shields. It only does extra damage to a specific resource. This would be a very specialized attribute. And so being able to change the damage under specialized conditions as we're doing our damage calculation is a really powerful tool. Modifiers also are useful for potentially canceling an event outright, right? There's a modifier in our game for, there's an event associated with dying. And a modifier can just say, don't though. Actually, what if you're still around? Another really nice thing for this is doing those non-numeric modifications to events. A thing that we use modifiers a lot for in Towerborne is to change the reaction that an attack will do. So, hey, maybe this attack normally does a heavy reaction. Now it does a ground bounce, so a player gets a full combo off of it and gets to do cool stuff, right? And so these 3 particular use cases make the ability to not only react to events, but to modify them as they're happening, a very powerful tool. And so we ended up with this sort of like whole perk family tree of abilities, which are actions you can take, passives that are attributes that you can change, triggers that are events you can react to, and modifiers that are events that you can change as they're happening. I'm pretty happy with this design. As I said, all the perks we came up with sort of fit into one of these buckets, so that's a good sign. Another good sign is that we're probably on the right track as far as a foundational design is that it's kind of boring. Triggers and passives are a thing that you see in card games and other sort of games, RPGs in particular, so like we're not going too far off the range there. And the modifier idea is largely borrowed from like UI paradigms where events bubble up and down a series of widgets, and then those widgets can modify or cancel the event as it's happening. So we're borrowing from well-established ideas, which is a great thing for these sort of like foundational systems that are going to prop up other stuff. Another index that I use for a design is probably on the right track is that it looks really obvious, but only in hindsight. Before, when we were looking at the goals, we were like, flexible and powerful, what does that even mean? Well, now we know, it means this, and you look at this stuff, and like I said, it's kind of boring and obvious, but it wasn't sure how we were going to get there when we started this whole process. Now that we're there, it seems very obvious how couldn't we get here. And so it's not 100% confirmation, but it's a good sign that we're on the right track as far as the design goes. Just to sort of like apply this from the perspective as a systems designer looking at a system, we'll look at an actual system from Towerborne. One of our classes can block, and so we're going, what are the abilities, attributes, and events that we care about? In this case, the design allows for blocking and also parrying, so those are new abilities we're going to have to support. We're also going to need a new attribute. Blocking reduces the amount of incoming damage you take. OK, by how much? We probably want our perk system to be able to change that. Skills and items want to adjust that. The events are kind of obvious. You blocked or you parried. OK, cool. We need to support that. And we also might want to change some things about the blocking and parrying, like can an attack even be blocked or parried? How much damage should this particular attack be reduced because you blocked it? And those are modifiers that we want to adjust as the event is happening. And I kind of recommend looking, when you're sort of like going, we're installing RPG stuff into our game, looking at it system by system like this, it's at the point a systems designer is designing a system that they have sort of the best visibility and the best like sort of understanding of the system to produce a list like this. And so if you have an RPG that you want to modify in random ways that you don't know about ahead of time, I would make generating a list like this a requirement of your systems design process. If you're designing a new system, you should have this list at the end of the day. All right, so we have our perk family tree. We decided we want to make perks. We know what our categories are, how we're going to implement each one of these categories. The first one is the new abilities, right? The cool buttons we want to push. And listen, man, you're using the gameplay ability system. Like, you already got the tool. It's here. It's great. Why did you even come to this talk, right? And honestly, it's kind of the same story as passives. You have numbers that you want to change when you equip an item. Like, just use gameplay effects. All right, cool. And like, yes, we're going to go past gameplay effects very briefly, but there are a couple things I want to bring up about them before we move on. The first one is, hey, if you're using gameplay effects for something you can equip and unequip, make sure that they're infinite duration. Designers making gameplay effects can use instant durations, and if they're just testing something real quick in the editor, it will look very much like it works until people start equipping and unequipping stuff. So you might even want to like validate this. If a gameplay effect is applied directly by a perk, it almost always wants an infinite duration. Another thing I talk to people who use the gameplay ability system about that sometimes don't know about this is this ongoing tag requirements that exist on the target tag requirements component that says, hey, this gameplay effect only exists or is only active while you have some specific other tag. The example perk on the screen generates a resource the whole time that you have a specific status effect associated with it. And this perk was implemented with a single gameplay effect with an infinite duration like we just talked about. It's also periodic, so it's constantly ticking and constantly generating this resource for you. Except it's not. Because of the ongoing tag requirement, it's only active when you have the associated status effect. So this is an easy way to do fairly complex conditional passives even within a single gameplay effect. And so this can simplify your implementation a bit. So that's my gameplay effect tip and trick, I guess. The second category is triggered abilities. And I mean, listen, it says abilities right in the name. Like, we've already got abilities. Let's just roll with it. And the thing about using abilities in this way is much like gameplay effects, gameplay abilities are very flexible, very complicated, can do a lot of things. They're kind of like these really great modular bits of arbitrary code you can just like stick onto the side of an actor. They're kind of like mini components. So to make them serve the function of doing triggered abilities well, we had to do a little bit of work, put in a little bit of infrastructure. And before we move on, we're going to talk about how we did it here. But I want to make it clear that every triggered ability basically follows the same formula of when this cool thing happens, if some set of conditions are true, do a thing. In fact, do I even, this is a good example of it, right? This says, hey, when you get hit with an attack, if it was a parry, gain the status effect. All right, cool. So to know when events happen, to do the first part of it, the relevant systems need to tell the relevant actors that the events happen. So the first thing you do if you want to support triggered abilities in this way is you just litter the game with gameplay events. And these are gameplay events. These are the things that like have a tag and a gameplay event data associated with them. So the second part of doing a triggered event is filtering it, right? Checking whatever conditions you want to do to see if this is the triggered ability that you actually care about. So the next thing you need to do is pass in any relevant data about the event in the gameplay event data. And yeah, this of course means all the relevant actors involved, who's doing the attack, who's getting attacked, but also any transient data associated with the event itself. Did this result in a crit? What was the reactions that the characters involved played? So that your triggered abilities have as much context as they need to do the actions that they want to do and do any filtering that they want to do. And there's kind of two ways to pass data through to a gameplay event data. There's the optional object, which is just an object that you can pass through. It's the sort of blueprint equivalent of a void star pointer. There's also the target data, which is designed to be this kind of opaque struct that represents who this ability is actually trying to affect, but it's kind of an arbitrary struct, and we abuse it quite a bit to pass through just random data. We do this, our engineers didn't super love the idea of using optional objects. They were worried that if they were creating small ones for every different event type that they created, they'd eventually run into garbage collection issues. So that's why I use the target data. I think either one of them would work, but also I leave performance up to the adults. They did this, so that's what I'm going to recommend to you here. And so this is sort of the broadcast part of it, right? The relevant systems need to broadcast these events to the relevant actors. They need to pass in as much context as they can. And then on the receiving side, when we want to implement a triggered ability, we use a gameplay ability that triggers off the associated tag. We check any of the conditions that we want to check to see if this triggered ability activates. And notably, we do it before the ability activates. There's this ability respond to event function that you can override on abilities that this fires off before the ability boots up. Activate ability will never get called if you return false from this ability. So you can do this. So you might have 10 different triggered abilities that go off of attack hit. It's a very popular event type, but they're not all going to go off every time you hit a person. You can make most of them early out, and only not early out if it's actually relevant to them. And then finally, we do the action, right? Like, we're subscribed to the right event because we have the right tag. We're checking our conditions and our should ability respond to event function. And now we need to commit so that our costs and cooldowns get paid, do our action, which 90% of the time is just apply a gameplay effect, and then end the ability immediately. Almost all of our triggered abilities end right away. There are some exceptions to this. We'll look at one later on. But for the most part, you just want to end right away. And this works really well. We're really happy with it. But this is kind of a lot of stuff to remember for designers. So the process for this, designers, like, we created a set of trigger base classes to make this easier on designers. Every event type has its own base class. If a designer wants to make a new triggered event, they inherit from the correct base class. It already knows how to respond to the correct tag. All of them are server only and do not replicate, with the idea that if a designer needs to worry about replication, they probably need to go call in the cavalry. And we expected that to happen some. It hasn't. I think technically all of the shipping perks in Towerborne are still server only and do not replicate. a lot of times those abilities create side effects that eventually replicate. They spawn actors, they apply gameplay effects, they send out cues, but the perks themselves all live on the server, and that's worked really well for us. Second, I guess third, these base classes know how to unpack the appropriate data. If you pass in an object through the gameplay event data, it's just an object. You're going to have to cast it to the right thing, and the right thing is going to be different per event. And so our base classes know the right way to do it. If you use the target event data, they're going to have to fish that data out of the target data somehow. And so, again, the base classes are the thing responsible for turning the kind of gobbledygook that the gameplay event data passes through into actual actionable context. The base classes also check common conditions. 90% of our attack hit events, like attack hit goes off even if an opponent blocked an attack. 90% of the time you don't want to do anything about it. And so our base classes check a lot of the sort of like foot guns, like is this character dead? Maybe don't do anything for you. Players of Towerborne note that this is a bald-faced lie, and actually we have 1 million perks in the game that actually do affect blocking characters. That's because we added this feature late and didn't have the guts to turn it on all of our old perks. So enjoy that while it lasts. We will probably fix it one day. In the same vein of like kind of trying to make the base classes provide sensible defaults, the base classes also automatically commit the ability and automatically end the ability. And again, implementers of Towerborne will note that the thing where we auto-commit is not always true. But come on, we know that it should be. So if you in the audience are doing this, please make your trigger base classes auto-commit. And so that sounds like a lot of stuff. What does this actually mean from the perspective of a designer, right? Well, we know that there are the 3 steps. When an event happens, check your conditions, act. OK. These line up specifically with the 3 actions that designers need to take to implement a triggered ability. One is inherit from the right event. That gets them responding to the right event. The next is override a function that exists on our base classes to check the conditions. And the third is to implement, to override another function that actually does the action. And we'll look at a real-world example. This is a real skill that exists in the game that says, basically, hey, if you break someone's block, if you cause a block-breaking reaction, get a cool buff. And so when you hit an enemy, if the reaction is a block break, get this gameplay effect, right? And so the first thing we do is we inherit from the right base class. That's the attack hit base class. Second, we check if the reaction caused is actually the block break that we want it to be. And if so, we return true. We're actually going to go off. And then the last thing we do is we apply a gameplay effect. As I said, 90% of the time, this function just applies a gameplay effect. And that's it. That's the whole implementation of this perk from a designer's perspective. Inherit from the right base class, implement one node function that has literally 2 nodes in it, implement another function that has literally 1 node in it. So it's fairly straightforward if you know what you need to do. And that's pretty much it for triggered abilities. That's how we do it, and it's been pretty successful so far. Next is modifiers. This is the one where you have highly conditional numeric attributes you want to change. You want to cancel the event entirely, or you want to like substitute some part of it. And like when we reached into the gameplay ability goodie bag, we didn't really find anything. We kind of had to roll our own. We came up with this idea of modifiers. We named them something stupid. For the purposes of this talk, though, I'm going to call them modifiers, which are objects that have a single function associated with the event that they're modifying. And that function is very simple. It takes some inputs. It produces some outputs. That's literally it. So this is an example of our outgoing damage modifier. It is, again, our most popular one, right? Attacking. This is a game where you attack stuff. And it takes a bunch of inputs about the context, and they can produce outputs that say, hey, this attack should do more damage. It should be more likely to crit, that kind of thing, right? And this actually works really well, right? This is an actual perk from the game that says, like, hey, if this is a shield attack, do more break barrier damage. I think we looked at it earlier. And from the perspective of a designer, it just looks like this. Create one of these object types, override this function, do your stuff in it. At the end of the day, on the back end, it looks like this. This is part of our damage formula. I hate it. It's ugly as hell. I'm not proud of this, y'all. But if you look at the core of it, it's actually like fairly straightforward, right? It gets all the appropriate modifiers from the appropriate people. In the damage formula, it's like who's getting attacked. We want to know all of their outgoing damage modifiers. Who's getting attacked. We want to know all their incoming damage modifiers. For every one of those objects, we run the associated event, and then we aggregate all the results. That's pretty much all there is. And so sometimes the actual execution of the modifiers is gross, but from the perspective of designers, it's pretty straightforward. And that's it. That's our perk family tree, right? Like, of all the 4 perk types that we said that we had to support to support that entire like giant spreadsheet of stuff, we covered all of them. And 3 of them came out of the box, right? Abilities just use gameplay abilities. Passives just use gameplay effects. Triggers use gameplay abilities, but you're going to have to do some stuff. And then the last one's the modifiers, and that one we had to roll our own. But you want to roll your own because they're very powerful and they allow a lot of weird effects that you otherwise wouldn't be able to do. And so all of these are good, but designers implementing perks don't add them directly to players. They actually add them to a perk object that is sort of the wrapper for this whole thing that speaks to a lot of the other goals that we talked about at the start, like tunable parameters and stuff. The perk object, obviously, yes, does grant the player gameplay effects, gameplay abilities, and modifiers like we already talked about. It also has a set of set by callers, and this is the way you can tune perks in one place without having to know how that perk is implemented. There's just a series of numbers and tag pairs up at the top here that balancing designers can adjust fairly easily. And these set by colors get copied to every gameplay effect that the perk applies. They're also accessible from the gameplay abilities and the modifiers associated with them. Gameplay abilities have set by colors. I didn't know if you know that. It's a weird thing that's hidden. They're not accessible by default, but they are there. And another interesting thing is these set by colors are accessible from the UI data that also lives on the perk object. So if a balance designer does change some number associated in the set by colors, it'll update the description automatically. They don't also have to update the text, which is nice. Another thing, we'll look at a specific example of this later, but some perks require multiple triggered abilities or multiple modifiers to implement the entire scope of their gameplay. And sometimes those different abilities want to communicate with each other somehow. And so all of the abilities and modifiers get references to the perk object and can stash data on it. And this allows perks to save data across each other, but also isolates them from each other so that one perk can't stop over information from another one. So that's pretty much what the implementation story looks like for designers. We're going to take a look at some real-world examples of perks that ship in the game and how we implemented them. The first one is this rumbling elbow drop. This says when you do this specific attack and you're at least a specific height up off the ground, you spawn a shockwave when you drop. It's a cool ability. It reuses that shockwave thing. I like it a lot. It's a classic triggered ability, right? When an event happens, if a set of conditions is true, spawn that cool shockwave. The event that we want to react to is the move committed event. This is every time a player does one of their attacks, we fire off an event. This is not all abilities. This is just like the player attack abilities. And so that's the event we're inheriting from. In our should perk respond, we check the 2 things that we actually care about. If it's specifically the attack that we're responding to, and also that we're a certain amount above the ground. And then when we handle it, we wait till the player hits the ground, and then we spawn a shockwave. And if you're willing to go with me on completely hand-waving what a shockwave means, this is a super easy perk to implement. Notably, we also say, like, hey, if you end the move before you hit the ground, we probably just want to bail out. That means you probably got hit, and we don't want to spawn that shockwave after all. And this is an example of, even though I said most of our triggered abilities end immediately, this one doesn't. So it's got to like call back to the event graph, and then we can use latent tasks and do all that cool stuff. And it's pretty straightforward to implement, even though this one's a little weird, right? All right, so the aspect of brutal combos. This is an aspect that you can get that gives you ramping damage every time you hit an opponent. Great. It resets every time you get hit. OK. And so we implemented this one with 2 triggered abilities and a modifier. They're all very simple, but there's several bits of the puzzle working in concert with each other. And this is where we're going to use that data store that we talked about earlier. The first one says, when we hit someone else, yo, bump that number. The second one says, when we get hit, make that number 0. And the third one is a modifier on outgoing damage that says, hey, what is that number? Use that to increase the damage. And that's it. So there's a lot of individual components with this particular perk, but they're all very simple, and they all work in concert with each other, using the data store to communicate between each other. And Yes, we probably could have implemented this perk with some sort of like stacking gameplay effect, except for we couldn't because of vagaries of our damage formula. Don't worry about it. We did need to use all this pipeline stuff. The last one that I want to talk to you guys about is Valor. Valor is an entire game mechanic associated with exactly one of our classes that says, hey, there's a meter. That meter fills up when you do gameplay actions, when you attack opponents, when you defend attacks appropriately. When that meter is full, there's a button you can push to turn a cool mode on. And while that mode is activating, you get some buffs. So it's sort of the classic like install super thing, right? And we actually implemented this entire gameplay mechanic in one perk. And I'm not going to go over the individual details because there's a lot of stuff that it does. It adds a HUD element to the player so that they can see the meter that they have. It initializes the mechanic's attributes so that like the max weapon meter is appropriate. It gives you all the abilities that gain that meter so that when you attack, when you respond to attacks, like when you parry successfully, basically, those triggered abilities go off and increment your meter. It adds the activation ability to you, and it also adds the passive abilities that, just like the examples we looked at earlier, are infinite but have ongoing tag requirements that say, well, they're only active in Valor mode. And so this whole gameplay mechanic is wrapped up in one perk, which means we can turn it on and off for playtests. If we ever want to make it's equipped all the time on players, but if we ever, or at least players of the appropriate class, but if we ever wanted to make like a variant of it so you could swap it out and add something else, we could just turn this whole thing off. And so that's some real world examples. We talked about like why we built the system. We talked about how we were going to design it. We talked about our implementation strategies for the whole thing. Does it work? And I realized that this is an ominous slide to ask that question in front of. I get it. But actually, we are pretty happy with how it works. What are the metrics I'm used to doing that? First, designers are crazy productive in it. Once they're ramped up, like this will be different for your game, but our sort of like metric for it is like a designer can throw out 40 perks in a month, which is a lot. Another metric is, hey, does it crash? Do my engineers hate me? They don't hate me because the game crashes. And then the third thing is like, does it work for designers? Does it let them do all the things that they want to do? And we've had very few instances of designers needing to redesign their perks because of some limitation in the system, with one exception that we will talk about in this section. So overall, pretty happy with it. But there's some stuff that if you're doing any of the stuff we talked about today, you'll want to address, like infinite loops. The classic example of this is Thorns. It says, hey, when I get attacked, I want to do some damage to you. If you have that same thing, then you're going to attack me, and now we're both very unhappy. Our current method of resolving this is please don't do that. And we had a designer put a Thorns effect on one of the enemies, and I helped him do it. But I said, hey, as payment for helping you do this for your prototype that you swear you're not going to ship, the first time you put a Thorns effect on a player, you need to come tell me about it, because we're going to have to solve this problem. A week later, he had a Thorns effect on a player, forgot to come tell me about it. It's a thing that you're going to have to keep an eye out for, and it's a thing I wish we had some fundamental protection against, and that you should probably install. Another one is operations, so order of operations. So one of the cool things that modifiers can do is change non-numeric attributes about an effect, like, hey, we want to cause a different reaction on this attack. You might have one modifier that says, hey, this attack now launches opponents, so you can do a cool combo, and another one that says, hey, this now causes a ground bounce, so they can do a cool combo. Which one are you actually going to get? I don't know. So you probably want some sort of priority or arbitration system associated with this. The last one is, hey, I showed you that spaghetti blueprint. It was gross. I don't want to do another one of those. Also, the way we ended up implementing modifiers, every time we make a new event type that we want to modify, engineers need to get involved. And so there's a lot of things in our game, particularly around resource granting, that I wish we had modifiers for. Those would open up a lot of perk possibilities that we could implement, but we don't because it's annoying. And so there's just this like latent design space that is there and would be explored if modifiers were easy to install in the places that they don't currently exist. And so when I said that, like, hey, for the most part, designers can do everything that they want to do, the places that designers couldn't do the stuff that they wanted to do were places that we should have had modifiers and didn't. Okay, the sort of like last main thing in the potential improvements thing I want to talk to you about is trigger conditions. I said that when designers are ramped up, they're incredibly productive, and that is true. Once designers hit the ground, they really go. They create a lot of perks very quickly. I spend a lot of my time doing code reviews. But the thing that takes a long time to ramp them up on are, we said that triggers followed that formula of when an event, check some conditions, do the thing. The conditions, to check the conditions, you need to know about how the associated systems in your game will work, right? And that's just a lot of surface area for designers to know. If you want to check if a character is in the air, you need to know about character movement modes. If you want to check about status effects, you have to know that we have a specific set of tags associated with our status effects that you should check. There's just a lot of domain knowledge that they need to learn. Our sort of solution that we're going to try for this is we want to create reusable filter objects that we could use across different trigger types. So we only have to write, hey, is this character in the air once? That can check the associated movement mode and do the right thing. And then we could just use that across all of our triggered ability types. But we haven't done that yet. And so this is still one of the biggest parts about ramping up new designers onto the system. And I would love to make it easier. And you should also make it easier if you're going to do any of this stuff. So that's all the improvements. One of the things I do want to talk about that is kind of a weird quirk of this system is a lot of the things that the perk object that we went over did, gameplay effects already do, right? Gameplay effects can add other gameplay effects. Gameplay effects can add gameplay abilities. They already have set by colors, and they also have some sort of notion of UI info. And that UI info is basically left up to like, yeah, you should implement one of your own. And so you can implement one of your own. When we first made the perk system, gameplay effect components didn't exist, and so we didn't have any way to add modifiers, so we at least needed some way to do that. And the perk object simplifies down into a lot of properties. Gameplay effects are very complicated, but theoretically today, you could do a lot of the modifier stuff in particular with a gameplay effect component, but I don't know how you would do the data store stuff. Like, you have options, right? Designers, particularly designers from MMO background, want to store integers in gameplay effect stacks, and that does work, but it is gross. They're terrible and hard to query, particularly if you want to know gameplay effect stacks on a specific that like you specifically caused. If you only need to track data across one instance of a triggered ability, I mean, triggered abilities are just blueprints. They can have variables, and if they're instanced by actor, those variables will persist across executions. You can use the sort of like normal ways you store data in the gameplay ability system and in Unreal on components or attributes, and all that stuff works, but you don't get the perk local storage. I don't know how I feel about it at the end of the day. If you're implementing something like this, you might consider just using gameplay effects and not bothering with the perk object. I think that it does give us a lot of cool stuff, and it is also like nice, easily editable small component that kind of hides a lot of the implementation details away. It's probably worth exploring it either way if you're doing it today. That's pretty much the talk. We're kind of done now. The things that I think that the most important things that I think you should probably leave this talk are is the core design. Even if you're not using the gameplay ability system, this abilities, passives, triggers, modifiers idea is a good design that we borrowed a lot from other games. We think will probably work for your game. You can probably just lift it entirely. Furthermore, 3 of the 4 of these already have good answers for it in the gameplay ability system if you want to use it, and in the case of triggers, set up the associated infrastructure around it. And so like, you're already off the races for a lot of this stuff. And finally, the last one isn't really covered that much. That's the modifiers one. You're going to have to roll your own thing for that, but I think that you really should roll your own thing for that because it's going to unlock a lot of design space and a lot of power for your designers. And that's pretty much it. If y'all got questions, there's a microphone up here. And other than that, we did it, y'all.